Okay, welcome. In this video, we're going to be talking about division, how to divide, and some of the key components about division that some people do get confused, probably because we're a little out of practice. I think a lot of us nowadays have cell phones or access to a calculator of some kind that allows us to forget a lot of the rules that are related to division, especially when you got to do division by hand. So if you have if it's a test or an exam, you want to know how to do these things by hand. So that's what we're going to be covering today, okay? So let's go ahead and get started. So I have the first thing up here. I have the word quotient refers to the answer of a division problem. So sometimes we have word problems that, they express a problem, an operation, using words, and sometimes we don't always know what those words mean, and we kind of get lost in that word problem. So quotient they're telling you to divide. All right, so if they say like the quotient of 6 and 3, they're asking you to divide 6 divided by 3. And just a quick recap: product means multiplication or the answer of a multiplication. Sum means an addition, and difference means subtraction. Just to keep those little things in mind. Vocabulary is always important in math. Okay, so pay close attention to the placement of the decimal point. It's not like what we see in multiplication, where we put the decimal at the very end of the operation. We do all the multiplying and adding at the end, and then the very last thing we do is place the decimal. It's not like that in division. Sometimes in division you have to locate or place the decimal in its final spot in the answer before you even start dividing. And other times you kind of figure out where the decimal goes halfway through the problem. So we've got to pay attention to that. All right. One thing that you never do is do it at the very end. It's always kind of midway to beginning to the middle of the problem, where you have to put that decimal in its place. After you use a decimal, if you use a decimal, you can put as many zeros as you want after the decimal. So we're talking about to the right-hand side of that decimal point. You can just keep adding zeros until you want to stop, or until the problem finishes. So that's a nice thing to keep in mind. And always practice good organization. Organization is important in all math, okay, in all of mathematics. And maybe even just a good thing to have in general, right? So, okay. So I've done a little bit on division when I talk about fractions, because a fraction is division. So we'll be looking at some of that today too, not in any detail, because that's not really what the purpose of this video. But I do want to talk about the first few examples in that sense as well. So the first one we're going to do is 45 divided by 9. And now hopefully a lot of you would already know what the answer is. It's, if you're good with your times tables, you know that the answer is 5. But sometimes division can also be expressed in a fraction form, and this is what I was referring to when I was starting, right? I would say, well, it's also a fraction. So both of these say 45 divided by 9. Now, in the little house, I don't know, I know it has a word, I can't think of the word. I looked it up and I was like, I'll just say the little house. So the little, is it a radicand? I can't think of the word. Anyway, I'm sorry. So we have the little division house, right? And the first thing we have to know is which number goes on the inside of the house and which one goes on the outside of the house. So if we're looking at it in this fashion, it's the second number that goes outside, and the first number goes inside, okay? So it would look like this, all right? And if you see it in a fraction form, the denominator is the divisor. The divisor is the number that's outside. I do know that one. And the dividend is the one on the inside. So the denominator turns into the divisor, so the 9 goes outside. Now I have some students tell me it's the smaller number. The smaller number is the one that goes outside the house, and the bigger number goes inside. And that's not how it works. It isn't the size of the number that tells you the size of the amount of the number that tells you where to put it in the division. It's placement in the expression. So when you have it this way, it's the second one. When you have it this way, it's the bottom one that goes outside. Okay. All right. So when we divide, I'm going to go ahead and talk about these some organizational skills that we need to maintain, and we should try to visualize these little invisible columns that, well, I'm drawing them right now, and I'll probably do it on the next one as well, but whenever I'm dividing, I don't put the lines, but we want to maintain organization with these columns so that we don't get mixed up with our answer, especially when we have decimal points. This one's not going to have really a decimal point, but anyway. So what we do is we go 9 goes into 4 how many times? Or basically 4 divided by 9. And it doesn't work. 9 doesn't fit into 4. So we have to say that it doesn't fit. Now you can put a 0 if you want to. That's just optional. I really don't put zeros. I just, it's nothing. 0 means nothing, so I prefer not to write anything. But anyway, so then we go to the next column. When we're in the second column, we're going to be including both numbers as one number. So now it's going to say 45. So now we say, does 9 fit into 45? And yes, it does. It fits 5 times. And then we like to do the subtraction. So we go 5 times 9 is 45. You write down that answer, and then you say, well, you subtract it. So 45 minus 45 is 0. There's no remainder, so that's where it ends. Okay? That's pretty standard. I think most of us remember how to do that kind of thing. A lot of this should be a refresher, I would hope. And if not, that's cool. That's what we're doing here. So the next one I'm going to put is 27 divided by 5. Again, it can also be written in a fraction form, just so we start getting used to that. At your high school equivalency level, like GED or something like that, this is probably more common because in algebra, that first levels of algebra, they kind of want you to start thinking about division in fraction form. All right, so when we divide, the 5 goes on the outside, not because it's smaller, but because of its place in the division. 27 divided by 5, this one says 27 divided by 5. It kind of goes like backwards a little bit, I don't know. Well, from right to left instead of left to right. Some people say 5 divided by 27, and that's not what this says. This says 27 divided by 5. So I'm going to go ahead and put some of those columns again. This will probably be the last time I put the columns. I do it just to kind of, can you guys see that? Yeah, I think it can show. I'm putting them kind of light, but anyway. So let me just go ahead and start doing the division, digit by digit. So 5 goes into 2 0 times. It's too big. 2 doesn't have enough space to take a 5, right? So we can put a 0, and I'll put a 0 this time. Then we go 5 goes into 27 5 times. And then this is where we like to do the subtraction, right? We go 5 times 5 is 25. And then we subtract it. And again, those columns really do help keep things organized. I've seen students get very, very weird angles when they're doing these things. And it's important to try to keep the columns mentally at the very minimum, right? So we do the subtraction, we get 2. Now here's the point where we would normally add a decimal. And again, if you're trying to convert a fraction into a mixed number, this is as far as you have to go, right? We're basically saying that 5 goes into 27 5 complete times, and there's a remainder of 2. So that would look like, I'll just put it in red real quick. So we said it goes 5 whole times, there's your whole number, and there's a remainder of 2. The remainder is your new numerator, and your denominator doesn't change, just 5 2/5. So that's kind of where we get that 5 2/5. But again, we're not doing this conversion from an improper fraction to a mixed number. And if you haven't seen that, don't worry, there's a whole other video on that, so you guys can watch that. Okay. We're going to make this into a decimal. So what we do is when we have a remainder and we're finished with the original problem or the original numbers that they gave us, this is where we add a decimal. We add a decimal and we raise it to the top. And notice how I put the decimal right on that column line? So it's just organization, right? And then I can add, like I said earlier at the very beginning, I can add all the zeros I want to add. I don't think I'm going to need that many, but I'm just showing you that. After the point, you can just put as many zeros as you need. All right, so now we have another number that we can bring down. So we drop it, and then we check it. Okay, drop and check, drop and check. And when I say check, we're checking to see if the divisor will fit into that new number after we dropped the next number. In this case, is 0. So 5 goes into 20, yes, it goes into 20 4 times. And that would go in that column where the 0 is. Okay? And that's it. All right, not too crazy yet, right? All right. Next problem. Next example. It can be 1 divided by 8. And this is a good example where some students say, well, you put the smaller number outside the house and you put the bigger number inside. Again, I have to emphasize this a lot, but that really is not how we look at these. It's the denominator that will go outside and the numerator will go inside. Okay? Or if we're looking at it this way, the second number goes outside and the first number goes inside, underneath the house. Okay, so here we go. 8 goes into 1. No, it doesn't. So we have to add a number. We have to add a 0, but before the 0, we put the point. When we're going to be adding zeros, we add the decimal first and raise it to the top, and then we have the decimal in its correct position before we continue, okay? In the correct position where the answer is going to go. So then after the point, I can add zeros all I want, right? I'll add 2 for now. If I need more, I'll add more. So 8 goes into 10 one time, so the 1 will go over the 0 where it makes the number 10, right? And then I can go 1 times 8 is 8. Do my subtraction. 10 minus 8 is 2. I had to think about that. Wow. I was just thinking that sometimes this decimal isn't really necessary right here. You can actually erase it. I'll leave it there just to show it helps me keep my columns and my organization in mind. So I'm going to leave it. But anyway, so I'll bring down the next 0. So I drop it and then I check it, right? I drop it and I check it. So I dropped the 0. Now I have 20. Now does 8 go into 20? I'm checking to see if 8 goes into 20, and it does. It goes into it twice. So 2 times 8 is 16. I do my subtraction, 20 minus 16, and I get 4. So I still have a remainder. I already used the decimal, so I can add another 0, which is what I'm going to do. Now, sometimes some people or some students ask me, how do I know how far I should go? Well, my rule of thumb would be take it out 4 places, minimum, before you decide to stop. A lot of them will end in 2 or 3, but there are some that stop at 4, and then there's some that just don't ever seem to stop. So I would say if you take it out to 4 spaces or 4 places after the decimal point, you're doing all right. Okay, so that's just a rule of thumb. After that, then you can decide if you want to round it to the, to the 1,000th place or round it to the nearest 100th, whatever. But take it out more than just a couple, okay? So I dropped another 0. I'm going to check to see if 8 fits into 40, and 8 does go into 45 whole times. And there you go. So basically what we did, which I do in another video as well, we've converted a fraction into a decimal by dividing, because fractions are always a division. And that's how we would do this kind of division, okay? All right, cool. All right. So we're going to change it up a little bit now. We're going to start making the divisions a little more complex, just to cover all the kinds of divisions that you might run across, right? Let's see, 22. Okay, so this is 22.48 divided by 4. Okay. It does not say 4 divided by 22.48. It's the other way around, okay? All right, so we just can go ahead and start. My decimal's already here, and to be honest, I can already raise it to the top if I want. I can just put it up there because it's not going to move. And I'll explain that. I'll explain why it's not going to move in the next problem, okay? And it has to do with this 4. So just pay attention to what the 4 is. It's 4, it's a whole number. It's a whole number 4. All right, and that's why, but you'll see the difference when I do the next problem. So okay, we'll go ahead and start. So does 4 go into 2? No. You can put a 0. You can say that it fits 0 times. You can, but I'm just going to continue, and I'll go over to the next digit, the next 2. And so now I ask, does 4 go into 22? Yeah, it goes into 22. Goes into it 5 times. 5 times 4 is 20. So 22 minus 20 is 2. So there's a remainder, but I'm not even done with my original problem, with the original number, so I can just keep dropping the next digit down. Drop the 4 and check it. Does 4 go into 24? Yeah, it goes into 24. It goes into it exactly 6 times. So 6 times 4 is 24. No remainder. But just because I don't have a remainder doesn't mean I can stop. I have to continue at least and get through all the numbers that they gave me originally in the problem. So got one more to go. And 4 goes into 8. Yeah, 4 goes into 8 2 times. 2 times 8. 2 times 4 is 8. No remainder, so I don't need to add zeros to continue. It's finished. All right, so the answer is 5.62. Okay? So that was not too bad, but now watch what the next one's going to be like. And this is probably the hardest kind of division. I don't know if it's hard, but it's where sometimes we get mixed up with the rules a little bit. All right, so 1.2 outside, and then we have 35.04 on the inside. So 35.04 divided by 1.2. Okay, so now this is where I can't, this is where I have to place the decimal at the beginning. I have to do something to place the decimal in its correct location at the beginning, and I know that because of the divisor, the number outside the house. This number is a decimal. It's 1 point something. It's 1.2, but it has a decimal in it. And the divisor can't have any decimals in it. So it needs to be changed into a whole number. And so how we do that is we just move the decimal over. In this case, 1 position to the right. So no matter how many decimals you have, let's say you had, I don't know, let's just make up a number. What if we had this, right? And let's say that was outside the house. I'm not going to put anything inside the house, but this number has a bigger decimal, and we have to move the decimal 3 places till it gets to the house, if you want to say it. Basically, we're moving it all the way to the right of that number, so that this number now isn't 3.4 blah blah. It is 3,456 whole numbers. You see what I'm saying? So same thing here. We're going to change this into 12 and not 1.2. All right, so that's what we did. Okay, we can just imagine that we did it. This is 12 now. We moved it 1 space over to the right. Now, the decimal inside the house has to do the same exact thing. This decimal moved 1 place. This decimal is going to move 1 place. If this one moved 3 places, this one would move 3 places. Okay, and that's all there is to it. So I'll go ahead and do the same thing here, one place. And when it's there, then we put it here. We can just raise it to the top. So now the decimal is placed in its correct location, which is 1, 2, 3. It's after the third. Remember the columns. So it's after that third column. So yeah, that's how that would go. So that's where the point's going to be in the answer. Once I figure that out, then all this can just kind of fade away. I don't really need to pay too much more attention to that stuff. Okay. I will leave this decimal down here though. I will do that. Just, I don't know, I like to see it. It's just maybe a little weird habit of mine. But anyway, okay, so now after we have that done, now we can just go ahead and do the division. So this is a good example of how this division is exactly opposite of what multiplication is. Multiplication, we do all the multiplying, and then we put the point at the very end. Here we had to put the point in its correct location before we even started the operation, in this case division. So it's a good example of the opposite, how opposite it is, how inverse it is of multiplication. Anyway, 12 goes into 35 2 times. So it goes 24, right? That gives me a remainder of 11. Right? Yep. 35 minus 24 is 11. Have to think about it, and then I'll drop the 0. Gives me 110. And after I drop it, I check to see how many times 12, or the divisor, will fit into 110. 12 times 10 is 120, so that's bigger than 110, so probably it's going to be 9, right? 12 times 9. 12 times 9 would be 108. Again, multiplication tables are important. Do the subtraction, I get a remainder of 2, and I can drop the last digit, and I get a 4. I get 24. So drop it, check it, 12 goes into 24 2 times, and that's going to be the answer, 29.2. And that's where, well, that's where it finishes. 2 times 12 is 24. And we get the final remainder of 0, and we're finished. Okay? So that's, that's what it is. So just keep in mind that if you have a decimal in the divisor, you have to change that decimal into a whole number. Okay? Just by running that number or scooting that number over as many times as you need to make a whole number. And then do the same thing with the decimal that's inside here, okay, inside the little house thing. Okay, so here I gave you guys, it's like I usually try to do, a couple more problems. Please stop the video, give it a go, see what you get, and then I'll do it too. All right. So, how did it go? I always wonder how you guys do. You know, I wonder if you guys actually stop it or not. Stop the video, or you guys just sit there and watch me say stop and no one stops. Anyway, okay. All right, so here we go. I'll go ahead and start with this one. 43.08 divided by 0.06, okay? So, again, obviously I made these ones where we have to move decimal points on purpose. So we'll go ahead and start with this one. So we can't have a decimal, we have to make it a whole number. So I have to move the decimal 2 spaces to the right. And that would be 6, right? 6 whole numbers. But the decimal inside the house has to go 1, 2 as well. And then we just go straight up with it, right? So that's where the decimal is going to be in the final answer. So I'm going to go ahead and take all this away because I don't need it anymore. Now, of course, you wouldn't be doing this on your paper. You really don't need to. It's just a lot easier on a dry erase board, right? So we'll do that. Boom. Okay. Now we're ready to do the division. Okay. So 6 goes into 4. No. 6 goes into 43. Yes. So it goes into it 7 times. So I put the 7 over the 3. So I'm saying that it's 43, not just 4. So that's a very key point. That's what I use those columns for sometimes, right? Just to show that. Because some people might want to put the 7 over the 4. And it's not over the 4. It's over the 3. Because 6 doesn't go into 4. It goes into 43. Okay. Done with that. So 7 times 6 is 42. The subtraction of that will give you 1. You can bring down the 0. 6 goes into 10. One time, obviously, yeah, 1 time. And then so 1 times 6, 6. Drop down my remainder is 4. After I do the subtraction, I didn't show my arrows. Let's do that. And then 6 goes into 48, 8 times. With 48, and you're done. So 718, okay? Very good, very good. I'll just pull this guy back a little bit. All right, so for this one, it's the same thing. We gotta move that decimal point to 2 places. So that's what I'm gonna do. I can't have a decimal, I have to make it a whole number. So the point that is inside this number, inside the little house, also has to scooch over 2 places, okay? So 1, 2. Put the point, raise it to the top. That's where the point's going to be in the answer, in the final answer, right? Okay, so again, I'm just going to take this away to kind of clean it up here. All right, so now 25. 25 goes into 1, no. 25 goes into 10, no. 25 goes into 102, yes. So it goes into it 4 times, and I put the 4 over the 2 so that I'm saying that it's 102 and not 10, not 0, okay? So 4 times 25 is 100. And I do the subtraction and I get 2. I'll bring down my 6. 25 goes into 26 one time. So 1 times 25 is 25. I get a remainder of 1. So I have a remainder. I finished all of my numbers that they gave me in the problem. So now this is where, and I'm already past the decimal point. So I can add zeros as much as I want, right? I can add as many zeros as I need. So we'll just start with 1, bring it down. So 25 goes into 10? No. This is important. I have to show that 25 fits, or that it doesn't fit into 10, or I was going to say that 25 fits 0 times in 10. It doesn't fit, and I have to show that. I have to say it fit 0 times. So, I could have done the same thing over here. I could have said 25 goes into 1, no. 25 goes into 10, no. But zeros before any real number, like a 1 or a 2, everything over here doesn't matter. But after you start putting regular numbers down, like 4 and 1, and you get one of these where the 25 doesn't fit, or the divisor doesn't fit in that number, you got to show that it doesn't fit, okay? Just a very important little thing right there, okay? Hopefully it didn't trip you up when you guys tried it. Okay, so it doesn't fit in 10. I say it fits 0 times in 10. I can add another 0. Now I have 100, and yes, 25 goes into 100 exactly 4 times. And no more remainder, and we're finished. Okay, so that's a little lesson on division. Hopefully it was helpful. Maybe it was a refresher, right, of how to do these things by hand. Hopefully you don't have a whole lot of those to do by hand on an exam or anything. But it's a good thing to know how to do, I think. So just keep practicing. Remember your organization. Remember this idea of having to move the decimal point a couple of times, and then the one inside has to do the same thing, the same number of times before you can divide. And other than that, you should be okay. Okay, keep going. Practice makes perfect.